Hello students, once again welcome to our channel Physi Dive, and this is your teacher Alexi Rajan. Today we are here with a very important topic for class 10 NCERT, that is sign conventions for spherical mirrors as well as the mirror form. Without wasting time, we are diving straight to the class. So to the class. Sign convention is nothing but it is a sign, whether it is a positive sign or the negative sign given to the various attributes, that is image distance, object distance, height of the image, height of the object, like that. So while doing certain numericals, we need to find or we need to do numericals, so we need to give signs, whether it is positive sign or whether it is negative sign. So that is found out by this particular topic, sign convention, and the same sign convention we will study in the case of lens also. This is a scenario, and you can see that there is a spherical mirror and precisely a concave mirror, and here is a pole, here is a principal focus, and here is a center of curvature. So these are the things that you already know. Okay, now before studying this sign convention, we need to have some prerequisites, certain knowledges that you should know before studying sign convention. The first and foremost thing is that all the measurements are taken from the pole. Here is one condition. Let us imagine that there is an object here, placed here. So this is an object AB. Here the object forms an image like this is A dash. The distance from pole to this particular object, that is this distance, is known as what? The object distance, denoted by U. And here make sure that you always measure the distance from pole to object, that is the direction of the object distance will be like this. All the measurements are taken from the pole. Now what about the image? So there you can say the distance from pole to this particular image is denoted by V, and the direction of V is also from pole to the image. So there, this is the importance of this particular point, that is all the measurements are taken from the pole. So if I want to find out the focal length or principal focus, focal length, then the distance from pole, the distance from this particular pole to this particular focus, principal focus, is focal length, and then the direction of focal length is also like this. So here in the case of object distance, the direction is like that. Right? In the case of image distance, the distance is taken from the pole and the direction is like this. And in the case of focal length also, we can say the direction is taken from the pole and the direction is like. The second prerequisite, imagine that you have a source here. Just imagine that you have a torch. Now if I switch on the torch, you can see that the incident rays are moving like this. In the optics chapter for class 10, we are not using any special source for light. We are considering this source as the object itself. The object is kept there, and the light rays which are incidenting is starting from the object itself. That's why we are seeing the image on the textbook like this. That is, the object is considered as the source of light itself. So make sure that there is no special source given there. It is said that once, if I want to see, if you want to see my face, then the light will come from there and it will hit on my face, it reflects and it falls on your eyes and you can see me. And then my face is acting as an object, and in fact it is acting as a source of light itself. The direction of incident ray will be like this, because it is starting from the source to the mirror, the direction of the incident ray. It is not. This is about the source of light as well as the incident ray and the direction of incident ray. Always the incident ray starts from the object to the lens. Okay. Whereas in the previous case, we have seen the direction is found out from the pole to that particular object, because object distance, for example, object distance, if you have to find out the direction of object distance, then I will measure it from the pole. If I have to find out the image distance, I will measure it from the pole to the image, and then I will find out the directions. But in the case of incident ray, the ray will start from the object, so the direction will be from the object. So that's the prerequisites that you need to know while studying this particular topic, that is the sign convention for a spherical mirror. Three things you need to keep in your mind. First one is the incident ray, second one is the object distance, third one is the image distance. Just see the diagram. Now what will be the direction of incident ray? The direction of incident ray will be like this, right? Because it is starting from the object. So the direction of incident ray will be like this. What will be the direction of the object distance? Always the object distance is measured from the pole. So it starts from here and this is the direction, right? So the direction will be like this. Okay, direction of U will be like this. This is the direction of incident ray. Okay. Now, what will be the direction of image distance? For image distance is calculated from where to where? So the direction is from pole to image like this. So just closely observe the directions there. Here you can see that the incident ray and the object, they are in opposite direction, right? Here in this case, IR and the image distance, that is also in the opposite direction. That is also in the opposite direction. So in both cases, you can see that they are opposite. So definitely U and V will have a negative sign. So opposite signs or opposite means negative. So obviously same sign or same direction, then we will give positive sign. That means if you have calculated the image distance and that image distance is having the same direction as that of the incident ray, then we will give a positive side, or same side or same direction will give you a positive side. So how we can find out? We will just take another scenario and see how we can get a same side case. This is another scenario. You can see here, when I keep the object here, between F and P, then I will get an image behind the mirror, right? So in this case, if I want to calculate the incident ray, then what is the direction of incident ray? It starts from the object and to the mirror. So direction will be like this, right? Okay. Incident ray directions should be taken from the object itself. Now, object distance. What is the direction of object distance? Object distance is always calculated from pole to the object. So this way. So object distance will be opposite to the incident ray. I hope that you are getting the points. Now, what is the direction of image or direction of image distance? So image distance, the direction is taken from the pole to that particular image, and this will be like this. That is same direction as that of the incident ray, same side. Now, in the first case of U, you can see they are in opposite direction. Whereas in the second case of V, that is incident ray and V are in same direction. So here the case is that U is taken as negative and V is set as positive. So U is negative and V is set positive. So sign convention means we are comparing the attributes or image distance or object distance with the direction of the incident ray. With respect to incident ray, what is its direction? If you are getting opposite direction, then negative sign. If you are getting same direction as that of the incident ray, then it will be positive. So negative and positives are given like that. This is the importance of sign convention, and we can see this importance while doing numerical problems. Now, in the case of V and U, we got the sign conventions. So what about the heights? What about the heights? Height of the image, height of the object. What type of signs are to be given? This is what we are going to study right now. Okay, this is the scenario. Next scenario. There, I am keeping the object between C and F. Then I'll get an image here behind C. Okay. So in that particular case, you can see this is the height of the object, and I am denoting this as HO, that is height of the object. And this height of the object is erect, or if you can see that thing, it is above the principal axis, There, the height which is above the principal axis is given as positive, whereas height which is below the principal axis, that is in this case the image is having, or it is inverted, image is inverted, that is the direction is from axis to downward. So we can say that thing HI, which is the other denotation of height of the image, which is given as negative. And now if I just keep the object, another object between F and P, then I will get the image like this, right? Virtual image. In this case, you can see that thing, both HO and HO and HI, which are erect. So we can say that thing, HO will be positive as well as HI will be positive. So it is like the same as that of what? The mathematical Cartesian coordinates. Above it is positive, and below it will be negative. This is what we need to know about the heights of the object and the image. This is what we are studying in the case of sign convention. I hope that you got the point about sign convention. Now we are diving straight to a very important topic, that is the mirror formula for a spherical mirror. So here comes the next scenario for mirror formula, and you have a spherical mirror, which is nothing but a concave mirror here, and here the pole is denoted, the principal focus is there, and the center of curvature is here. Now all the measurements are taken from the pole, so here you got the distance from pole to the object as object distance, the distance from pole to the image as image distance, and the distance from pole to the principal focus, that is a focal length here, which is also measured from pole to that particular principal focus. And all the three values are there, U, V and F. That is U, V and F. There is a special equation which relates all the three terms, that is U, V and F, and which is nothing but the mirror formula. So the mirror formula goes like this: the reciprocal of the focal length is equal to the sum of reciprocals of the image as well as the object. So 1 by F is equal to 1 by V plus 1 by U. This is the mirror formula. In 12th standard, you will find out more general equation for the mirror formula. This is the mirror formula. Now, what about magnification? Magnification is a very important term. So imagine that you have an object here, and the height of the object is HO, and you got the image like this. That is, this object is AB and the image is A dash B dash, and it is denoted by HI. So clearly observe, there you can see it is the object and the image are of different size. The height is differing. So here I am comparing the height of the image which I got with respect to the object. So there comes a new term, that is magnification, denoted by M, and it is given by the height of the image to height of the object. That is how I am comparing my height with respect to my image height. This is what is given by magnification. So M is equal to HI by HO. And if I only know about two terms, that is V and U, then also no need to worry, we have equation for that too. That is magnification is equal to the negative of V by U. That is two equations you are getting, that is HI by HO as well as minus V by U. And in both cases you will get numericals related to this equations, and you can use both equations according to the question. See, if HI and HO is given there, then you can find out the magnification by this equation 1, and if you are given with U and V, then you can use a second equation and find out the magnification. Certain conclusions are there in the case of magnification. If we are getting a magnification M is equal to 1, what is the meaning of that particular statement? M is equal to 1. M is equal to 1 means HI and HO are equal. Then only you will get the value M is equal to 1. So HI is equal to HO. It is nothing but both image and object are of same size. If M is less than 1, then obviously HI should be lesser than HO. That is, object will be larger and image is smaller. In the case of M is greater than 1, that means HI should be greater than HO. That is, image will be larger. This is the inference. That is, equal to 1, same size, less than 1, that is, object is greater or larger, and greater, M is equal to greater than 1, then you can say the image is larger than the object. This is what you need to study in this scenario. And U will always be negative. Why? You already know that thing. U means what? Object distance. And the incident ray is always from object to the lens or object to the mirror, whereas image distance or object distance is from that particular pole to the object. That is always they are in opposite direction. So they definitely you will be always negative. These are the certain scenarios, certain conclusions that you need to know while studying this particular session, that is sign convention as well as the magnification and mirror formula. So that's all about the magnifications. So that's all, and we are stopping right here in this session. And the next class we will come with new topics, that is certain numericals, very important numericals, as well as we'll start the lens case also. So I hope that you got the points there, and we need your support by like, share and comment, as well as your subscription. So we'll see you in the next class. Goodbye and have a nice day.